we know that a system consists of many number of components, and these components are connected together to perform some operations. So if we want to express the function of each component, then the transfer function of each component of the system, it is represented by a block diagram. So a block diagram is a symbol which is showing the mathematical operation defining the function of each component. So this is the definition of a block diagram. Let's see it again. A block diagram, it is a pictorial or symbolic representation of the functions performed by each component of a system. Now we have said that a system is having many number of components. So each component, it will be represented by a block diagram. That block diagram will show the functions performed by that component. And then the various components or the block diagram of various components, they are connected together, and hence you will get the block diagram for a system. So let us first see that what will be the block diagram of a component. This inward arrow, it is showing the input of the component. And the outward arrow, it is showing the output of the component. This block, it is showing the transfer function of the component. So this transfer function, it can be represented as GS. The input, it is represented as XS, and output is represented as YS. Okay. So these arrows, they are showing the direction of flow of the signal through the component. So the arrows, they are defining the direction of flow of signals. So this is the block diagram of a component. Now system is having many number of components. Such type of block diagrams, they are connected together to form the block diagram of a component. Like every component, the transfer function of every component, it is written in the corresponding block. Now we have seen that this is the block diagram of a component. So if we want to draw the block diagram of a system, then the corresponding components, the transfer function of those components, they are written in the corresponding blocks, and then these blocks, they are connected together with the help of arrows to show the direction of flow of signals. So let's draw the block diagram of a system. This system is having, suppose, three components. So we will draw the block for each component. There are three components, so three blocks are here, and for each component, the transfer function of that component is mentioned in the corresponding block. So the first block is having transfer function of first component. So let's suppose this transfer function is given by G1s. This is the second component. And this is the third component. So we have written the transfer function for all the three components. Now, this is the input of the first component and this is the output of the first component. And this output will become the input for the second component. Similarly, for the third component we have. So this arrow, it will become the input of the system. And this outward arrow, it will become the output of the system. So this is the block diagram of a system having three components. So we have seen that what is a block diagram and we have seen a block diagram of a system. Now let us study that what are the basic elements of a block diagram. The first basic element of a block diagram is a block. We have seen that a system is having various components. So in a block diagram, these system variables, they are linked to each other through functional blocks. So a block, it is a symbol for the mathematical operation which is performed on the input signal to the block which is producing the output. So how we can represent a block? This is the input to the block and this is the output of the block. Now, this input, it is represented by x's and output is given by ys, and the block, it is containing the transfer function of the component. So transfer function is represented by gs. So if we write the equation for this block, then it will come out to be ys is equals to the multiplication of gs and xs. So if we take the ratio of ys and xs, it will be equal to the transfer function. So this is the way in which we can represent a block. So block is the first basic element of a block diagram. Now these blocks, they can be connected in series or they can be connected in parallel. So how they are connected in series and parallel combination? This is block number 1. So if the output of the block number 1 is the input of block number 2 and the output of block number 2 is acting as an input to the block number 3, then such a connection of the blocks is the series combination of the blocks. So in this way, the blocks are connected in series. Now, if the same signal is given to as an input to the block 1, block 2 and block 3 and they are having a same output, the output is getting added up. So this in this way, when the blocks are connected, it is called the parallel connection of blocks. So these are the two ways in which the blocks can be connected. They can be connected in series or they can be connected in parallel. So the second element is summing point. As the name indicates, the summing point, it is used to sum up two or more input signals. Now, each input signal, it can have its appropriate sign. That is, it can have plus sign or it can have minus sign. If it is having plus sign, then the input signals, they are added up. And if the input signal is having minus sign, then subtraction takes place. Now the summing point, it is having only one output and this output is equal to the algebraic sum of the inputs. Let's see how a summing point can be represented. So this is a summing point which is having three inputs x1, x2 and x3. X1 input signal is having plus sign, x2 is also having plus sign and x3 is having minus sign. And the output of this summing point is x4. So x4 will be equal to the algebraic sum of these three input signals. So x4 will be minus x3. So the x3 is having minus sign. So we have taken minus sign here. So you can see that the output of the summing point will be the algebraic sum of the inputs. Now the third element of a block diagram is takeoff point. A takeoff point is used to allow an input signal to be used by two or more blocks. So through takeoff point, we can use a single signal and this signal can be used by two or more blocks or summing points. So let's see how we represent a takeoff point. So this is the takeoff point. Through this takeoff point, we can use the signal x1s in three blocks. This x1s is also given to the first block, also to the second block, and it is also acting as an input to the third block. So the output of the first block, that is y1s, it will be equals to g1s x1s. Similarly, the outputs of the second and the third block will be so you can see that the same signal x1s, it is used by three blocks. So in this way, the takeoff point help us in the block diagram representation. The fourth basic element of a block diagram is branches. Branches are the lines joining the blocks in a system. The example of branches is these are the branches. So these branches are the lines which are joining the blocks in a block diagram. Now the fifth component is arrows. Arrows are used in a block diagram to indicate the direction of flow of these signals in a system. Let's take this example. These are the arrows. So they are showing us the direction of flow of these signals. This is the input signal. So this is the direction in which the input signal is flowing through the system. So these were the basic elements of a block diagram, and we will use these basic elements to draw the block diagram for a system. We will draw the block diagram for a closed loop control system. This is the representation of a closed loop control system. So let's draw the block diagram for it. This controller and system, it can be combined, and we can have a block for it, which is showing the transfer function of this complete system. So this is the block diagram of a closed loop control system. RS was the input signal, or we can say RS is the Laplace transform of the input signal. CS is the Laplace transform of the controlled output. ES is the Laplace transform of the error signal. ES is called the error signal because it is the difference of the input signal and the feedback signal. So we can write ES as RS minus BS, or it is the what it is? It is the Laplace transform of error signal. GS is the forward path gain or transfer function of the system. HS is the transfer function of the feedback element, and BS is the Laplace transform of the feedback signal. And HS was transfer function of feedback element. So this is the block diagram of a closed loop control system. So till now we have studied that what is a block diagram, what are the basic elements of a block diagram, and how we can draw the block diagram of a closed loop control system. Now let's see that what are the advantages and disadvantages of block diagram. see the advantages. The first advantage is that block diagrams are very simple to construct. The second advantage is that the function of the individual elements or individual components of a control system, they are easily visualized in a block diagram. The third advantage is that the overall transfer function of a control system can be easily calculated with the help of a block diagram, because the individual transfer function of each component is represented in the block diagram. So when we solve this block diagram, we can find out the overall transfer function of a system. The fourth advantage of a block diagram is that if we know the function of each component, or the transfer function of each component is known to us, and we can also calculate the overall transfer function of the system. So by having the transfer function of each component and transfer function of each of the system as an overall, we can study the individual and overall performance of a system by a block diagram. So these were the advantages of a block diagram. Now let's see the disadvantages. The first disadvantage of a block diagram is that it gives no information about the physical structure of a component or a system. That what is the connections, or what are the various parts which are forming a component, and what are the nature of these components. No information is given by a block diagram. The second disadvantage is that the source of energy is not shown in a block diagram. That how the system is getting its energy, that is not represented in a block diagram. So these were the two disadvantages of a block diagram. So in this video, we have studied about the block diagram and the basic elements of a block diagram. Then we studied the representation or the block diagram of a closed loop control system, and after that we studied some of the advantages and disadvantages of control system. I hope the topic is clear to you. Thank you.